In a previous video I looked at a battery tester to analyse it, see how it worked, and what it included was an analogue meter. So if we have a look at an analogue meter, which is what I want to look at today, what we find is we open the front up. What we've got is a pointer that moves across, and it is attached to a coil of wire. I can move the pointer, but normally it will be the coil of wire moving that move the pointer. The pointer goes back to zero, because I don't know if we can see it. There's a very fine spring here, so it turns it back to zero. So when we pass a current through the coil, it tends to magnetize the coil. There's magnets down either side, so as the coil becomes more magnetized, gets a stronger current, a stronger magnetic field around it, more current, more magnetic field, then it moves across a certain distance depending upon the magnetic field. Last time I actually built an electric motor using wire and magnets and a thing called a commutator. This time I'm going to do a similar thing, but instead of using the commutator, just connect the ends of the coil straight out. So how does it work? Well, if we have a look at some little diagrams to start with, what we have, if we have a north pole and a south pole, and we stick a soft iron core in the middle, then the lines of force come across and give us a uniform sort of pattern. So it doesn't matter whereabouts in here, if we're going in a curve, we'll always have more or less the same field strength. There of course aren't real lines of force, these just represent the strength of the field. If we look then at a coil placed in, here we have a coil carrying current, or a current carrying coil. Then we show one side as a dot and the other side as a cross. The reason for that is one shows the current coming out and the other shows it going in. How can we remember that? Well, if we think of a dart, if you're looking at the flight as it's going away from you, you'd see the cross. And if you think of it as a dot coming towards you, you just see the point. So that just helps us to remember which way around it is. We then have the lines of force going round, or at least the magnetic field going round, which we can represent as lines of force. If we put the two together, then what tends to happen is the lines of force come round, or the magnetic field comes round, joins with the magnetic field here, and tends to push this side of the coil up, and the opposite occurs at the other side, so it tends to push the coil down. And that's exactly the same sort of setup in the motor as in the analogue meter. If we look at a diagram then of an analogue meter, what we have is we have our north and our south. We have our coil here going round. The current comes in through the spring, because it would be difficult to get a current in any other way, and the spring is a very convenient way to do it. It then goes into the coil, round the coil, comes round the other side, and then out at this end, again through the spring, and that then comes out. The stronger the current going through here, then the greater the magnetic field round it, and the more it will turn. So let's have a look at a model. The models I built, the first one I built, I used the same wire as on my motor, and that wire is a 0.5 millimeter wire. I've made it up so that the spring, it acts as the spring, so that if I push the pointer across, then it goes across but comes back again when I release it. What I need to do then is to apply some power to this. To do that then, I'm going to actually use a digital meter, which of course has its own power with it, unlike our analogue meter, which can be used without its own power. The power I'm using is going to come via a variable resistor so that I can alter the current through it, and it comes from a trusty X-vape cell, which of course has got a protection board on it. Wouldn't use it without. So what do we want to do? Well, we need to plug in our meter, or our demonstration meter. Of course this is no good for real life, but it does show us how it works. We then increase our potential variable resistor. We've got 20 milliamps, nothing really happening. 30, 40, 50, 60, 70, and at about an amp then it goes across, but it takes it about an amp or 2 amps there before it really starts to move. So there we can see that we can alter the position of the needle just by altering the current going into it. If I, of course, would have had a scale behind it so that we can see what the reading is. So that's using 0.5 diameter wire, and there's about 8 meters in length. Wasn't very happy with that, thought it took far too much current, so therefore I built another one which, similar idea, but instead of having the 0.5 millimeter diameter wire, I've used 0.25. Oops, that's probably broken it. No, it seems to work. So the wire at the sides is curled round, so that's what acts as my spring. So you've got the wire here coming round, acting as the spring to bring this back to what would be 0 if we'd got a scale behind it. So I've got this thinner wire, and I've also doubled the length, so I've actually got 8 meters of wire wrapped round this former here. Of course I've got no metal in between like there was on the real one, so we won't get exactly the uniform sort of scale that we would if we had our soft iron former in between. Of course it isn't soft iron in terms of you can shove your fingernail in it, it's soft iron magnetically. In other words, it loses its magnetism as soon as an external force is removed. So let's try this one. Is this one going to work? What we're looking for is to be able to untangle it. So we untangle, we take our connector, put our connector in so that that's there. We've lost our connector at this side, so we can reconnect that, and hopefully, if I've managed to get that right, if I can turn my variable resistor, then where we've got 10 milliamps, 20, 30 milliamps, and it's already moved, and then 70 milliamps it's gone, or well 200 milliamps it's fully across, and so therefore we can get our meter to move backwards and forwards depending on the current flowing through it. I don't know if that's clear. Let's try again. Increase it, goes forward, comes back, goes that way, depending upon the current on it. It isn't coming quite back for some reason, but you get the idea, the principle's there, that we have got a analogue meter which almost works, but it does show us the principle. So hopefully that's been useful. I've enjoyed doing it, so it's bye now. Bye.